All right, pre-calc students, couple things. We are starting a new unit today on vectors. And I was looking through my drawers during spring break and I found another math shirt. I know you're super excited, so I hope you can see it. Like, get close. It says, I ate some pie. It was delicious. This is my first shirt and my oldest one, so I don't wear it a lot to school because it's pretty old, but it's okay because it's just a video. All right, so I'm going to show you guys this little clip to introduce our new topic. It's like a minute clip. You'll really enjoy it.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ah! Gosh, it's so difficult sometimes to get the piranha back inside of me.
Okay, so I always like playing that because I think it's just funny. It's a funny movie. I'm sure you have tons of time on your hands, so watch it again if you need to. All right, so we are, hold on, where's my black pen? I just wrote, oh well, anyway, I'll use my other pens. So the clip said this, but I'm going to write it again. Okay, vectors have magnitude, okay, and direction. All right, so magnitude is just the length of it. So magnitude is how long it is, and direction is always measured from the positive x-axis. Okay, and it's always between 0 and 360 degrees. Okay, so just like the law of sines and law of cosines unit, we're going to use degree measure, not radians. And you don't measure, if it says direction, you measure it from the positive x-axis, like how far does it go, okay? If it says a bearing, then that's something different that we'll talk about. Remember, that's measured from like the north or south, okay? All right, so let's just do a pretty straightforward example. Number one, if you have graph paper, definitely use it on this because it's pretty important you have graph paper. So just pause this and go get yourself some if you need to, okay? All right, so the first one is I just want to put a point and I want you guys to go out 3 grid spaces and put an arrow, okay? So that is a vector, okay? Some people think it looks like a ray from geometry class, which it does, but the difference between a ray and a vector is a ray, actually the arrow means it goes on forever. In a vector, the arrow just means that that's the direction it's going, okay? So this one has a direction of 0 degrees, okay, because that's the positive x-axis. It has a magnitude of 3 because it's 1, 2, 3. So the length of it's 3, the direction is 0 degrees, okay? All right, let's say we had this one. Oh dear. Okay, and I want you guys to do a vector right in the middle like this, okay? All right. So first of all, we want to think how long it is. You guys are going to use your geometry for this. You're going to use your special triangles sometimes, and you will use your special triangles sometimes. If this is right in the middle, then you guys should know that these are both 45 degrees. So we have our 45, 45, 90 triangle, which means that if this is 2 and this is 2, you guys should know that the length of this is 2 root 2. X root 2. So that comes in handy. Let's say you completely forgot that. You could just use Pythagorean theorem to find that, but it just takes longer, okay? So this has a magnitude of 2 root 2. That's how long it is. And the direction is, this is 90. This is 180. Halfway between 90 and 180 is 135 degrees. Okay, so this has a length of 2 root 2 and a direction of 135 degrees. Okay, all right. So a couple little things. Yeah, a couple little things about vectors, just like the little details. Okay. One is that if you have a vector, they usually like to call vectors V or W or U. Those are the three most common ones. Let's say we had vector V and it went this way, okay? This is vector V, okay? If you wanted to draw negative V, okay, so negative V, that just means it has the same length, okay, but the opposite direction. Okay, so if you wanted to draw that, okay, you would just simply, go, so this is over 3 up 2, you just go over 2 down 3. Okay, so this has the same exact length as this, but the direction is completely opposite. So like one went north, one went south, one went northeast, one went southwest. That's the way this works. So that's V, that's opposite of V, okay? All right, and then there's this thing called a scalar. And if you remember from geometry class, scaling something means changing like how big it is, okay? So if we have a scalar, okay, it just means it changes how long it is, but keeps the direction the same. So if we have our vector V, we'll use the same one we had before. By the way, if you take a vector and you pick it up and you move it somewhere, it doesn't change it. So you can pick it up and move it wherever you want. So I'm just gonna pick up vector V and move it to here, okay? All right, let's say I wanted to do, 2V, okay? The 2 would be considered the scalar, and all that means is you just draw 2 of them, okay? And so see how the direction doesn't change, but now the magnitude is twice as big, okay? So that's what it means to be a scalar, okay? All right, so the first thing we're gonna do is we're just gonna draw some vector paths, and this is pretty important, okay? You'll use this when you take physics if you haven't already taken it, okay? All right, so what I want you guys to do is on your graph paper, okay, I want you to draw some vectors on your paper. Remember, it doesn't matter where you draw them, they just have to be exactly the same size as mine, okay? So I want you guys to draw a little vector V, which is over 2 up 1, so that's gonna be vector V, okay? Then I want you guys to draw W, which is gonna be up 3 over 2. Okay, and then I want you to draw U, which is over 1 up 2. Okay, so those are the 3 vectors. And what we're gonna do now is I'm gonna teach you how to add them together to form like a path, okay? It's kind of be like if you're going somewhere, going this way, then this way, then this, like where do you end up? It's kind of like that, okay? So let's kind of start out with kind of a nice basic one, V plus W, okay? So when I ask you to add 2 vectors, you just start with the one I give you. So here, remember, just pick it up and put it anywhere you want. So I'm gonna just pick this vector up and I'm gonna redraw it, keep it at the same length in the same direction. Okay, so that's vector V. All right, this is the important part. When you add a vector to it, you have to do the arrow to the tail, okay? So this W is gonna go right here on the arrow. And so you're gonna go from here up 3 over 2. And that's vector W. So this is what's really important right here. You don't want the arrows clashing and you don't want 2 tails to clash. You want arrow to tail, okay? And then we draw something which we call the resultant, which means, okay, you started here and your path took you in a weird direction, but your path ended here. So this is what we call the result, okay? So the result is from where you start pointing to where you end. And this one we happen to be able to tell you. If I said what is result vector, the magnitude, you would say it's 1, 2, 3, 4. So the result has a magnitude of 4 in a direction of 90 degrees. You're not always gonna be able to do that, okay? All right, let's do another one. Okay, this time I want you guys to do, I'm gonna use my blue, it's a little nicer. W minus U, okay? So this time we're gonna start with W, okay? So I'm gonna go up 3 over 2, because that's like the prescribed vector W. I could have, made it anything. And then instead of adding u to this, it's minus u, which means I'm gonna take this vector and I'm gonna keep the magnitude the same, but change the direction. So instead of going up 1 over 2, I'm gonna go left 1 down 2. So notice that this vector and this vector have the same exact length, but the minus makes it go the opposite direction, okay? All right, and then the result would be that I started here, I ended here. This is called the result vector. And this one, without doing some math, which I promise you we will do, it's really hard to tell exactly how long that is and what the direction is. But you can just label the result for now, okay? All right, we're gonna do one more of these, okay? I want you guys to draw 3u minus 2w minus v. It does not look like a v, hold on. Okay, and just a little heads up, this one's kind of tall, so give yourself some space right here. Okay, so I'm gonna go ahead and start mine like down here somewhere, okay? If you wanna pause this and try this on your own, that's a good idea, okay? All right, so it says 3u, that means that 3 is the scalar, and so I'm gonna just draw 3 u's. So I'm gonna draw u, and then another u, and then another u. So that's 3 u's. Okay? All right, and then it says I'm gonna do minus 2w, which means instead of doing up 3 over 2 twice, I have to do the opposite. So I have to go down 3 over 2, but I have to do that twice. Okay? So this goes the opposite direction, and twice as 2 of those w's, okay? And then it says I have to subtract v. V is supposed to go over 2 up 1. I have to do the opposite, so over 2 down 1, okay? And that's minus v, okay? All right, so then the result is that I started here and all this crazy path, I still ended up right here, so this is the result, okay? When I look at your homework, I want you guys to have those arrows on for me, because without the arrows, you can't tell what the path is, okay? All right, so you're gonna have some of these in your homework to practice. Okay, I'm gonna teach you one more thing today. Okay. Okay, so this is called algebraic vectors. Okay, so what we want to be able to do is we want to be able to name a vector by its, like how far over it goes and how high up it goes, okay? There's 2 ways to do it. One kind of fancy notation is you can have like this little bracket thing, okay? And then you can have 2 letters and then close the bracket, okay? This is how far you go in the x direction, and this is how far you go in the y direction, okay? And they don't call them x and y because those are the directions, but they want them to be numbers, so they used a and b, okay? Or you can write it out more formally like this. This is pretty confusing because you see i's and j's there. So they wanted people to be able to know that this was a vector. So instead of doing ax plus by, they're using i's and j's, where the I, okay, is exactly the same as the x-axis. So this is the I-axis and this is the j-axis, okay? So that's how you're gonna see it every single time. So they can leave the i's and j's off and use this cool notation, or they can write it like this with the i's and j's in there. And I'm gonna do both, okay? All right, so the first one, I'm gonna use the fancy notation. I'm gonna say vector v is brackety thing, 4, negative 1, brackety thing, okay? All this means, and we always start at 0, 0, even though you don't have to, it just is like the easiest. You start at 0, 0, and then it says you go 4, okay, in the x direction, sorry. So you go over 4, and then it says you go down 1 in the y direction. So it just tells you that your vector is over 4 down 1, okay? Easy as that. All right, let's draw another one on the same grid, okay? If I had w equals 0, comma 5. Okay, that means I go 0 in the x direction, so none this way, but 5 in the y direction, so it's 1, 2, 3, 4, 5. Okay, so my vector, let me draw that in a different color, it's hard to see. So my vector would be here. Okay, all right, and then just to practice one using the other notation, if you wanted to draw, if I wrote like this, vector equals negative 3i minus 2j, okay? That just means that in the I direction, which is x, you go over 3, and in the j direction, which is y, you go down 2, so this would be your vector. Okay, I should have called that something different. Let's call it u. Okay, so this one was v, this one was w, this one is u. All right, so hopefully that's pretty clear. One of the nice things about this is it makes them really easy to add and subtract, okay? So let's go ahead and clear this. Okay. Draw myself a new axis. Okay, so I want you guys to write down that vector v is 2i minus 4j, and vector w is negative 3i plus j. What I want you guys to do is draw v plus w, and then write the components. Okay, when they say write the components, that means like how far in the I direction, how far in the j direction. Okay, remember this is the I, this is the j. Okay, so it says v plus w, so you just start by v. So 2i minus 1, 2, 3, 4. Okay, so this is vector v. Okay, and then it says add w. Remember, when you add a vector, you have to start here. You can't start back at the origin. Okay, so from here, okay, you pretend like this is your new origin. You go 3 in the I direction, 1 in the j direction. So that's w. Okay, and then it says draw v plus w. Okay, so remember v plus w is the result. So I started here and I ended here. So this would be v plus w, which we call the result. Okay, and then if I asked you to write the components for that, okay, you would say that v plus w equals, and then so from here to get to the end, you go negative 1 in the j direction. So negative, that's like a weird 1. Negative 1j, or you can leave the 1 off, obviously. And then it's 3 in the j, sorry, I messed that up. Let's do this again. Okay, so in the I direction, it's negative 1i, because it's this way. And then you're going down, so it's minus 3j. Okay, or you can write it like this, negative 1, negative 3. Those are like the two ways to write it. Okay, sorry I messed that one up. Okay, all right, we're just gonna do one more problem today. Okay, this one does not involve a graph. Do I have? Yeah, let's use the same vectors. Sorry, I have to erase this though. Okay, so using these same vectors, I want you guys to do this problem. What is w minus 2b? Okay, so you could obviously draw this out, but sometimes when you draw it out, the pictures just get huge and it's kind of time consuming. One really nice thing about having them in this algebraic form is you can just treat it like an algebra problem. So you can just add and subtract vectors just like normal, okay? So actually, let's start out with an easier problem. Like if I just wanted to do well, we already have it. So like, let's say I wanted to do v plus w right here. See how we have 2i minus 3j? If you just literally add those, like add like terms, you get negative 1i, which is right here, okay? Here, if you just add those, negative 4j plus 1, you get negative 3. So I didn't even have to draw all those pictures to get the answer. I could have just added these and added these. So just adding like terms will get you the I and j component, okay? If it's a little fancier like this, just take your time with it. So it's w is this, and then minus 2, and then write the v. And then you can just treat this like you did in algebra class when your teacher asked you to add like terms. So negative 3i plus j minus 4i plus 8j. Make sure you distribute the negative. And then you add the i's, so you get negative 7i. Add the j's plus 9j. Okay. All right, so adding vectors, if you have their algebraic form, is just like adding like terms in algebra. All right, group. Try your homework tonight. Remember, I have Zoom office hours now that you could just pop into. You don't even have to tell me. I will be in my house with my Zoom on, and just pop in, ask a question. You can stay or leave after that. It's up to you. And if you're watching this before Wednesday or Thursday, remember, don't forget to come to our Zoom class, because we're going to have a live Zoom class every week, and I really want you guys all there. We're going to be doing problems during that time that will help prepare you guys for calculus, okay? And I just want to see you guys, okay? All right, bye, guys.